Hi everyone, welcome to my third and last video for review board for this semester. My name is Praise and my project is about using machine learning to suggest reviewers to users of review board. So in this video I'm going to quickly go over how I created an extension, the changes I made to my machine learning model from the last video, and then number three, I'm also going to go over the testing I did to test the accuracy or to check the accuracy of the model, and then do a quick demo at the end. So if we take a look at this page right here, guide extensions, writing extensions, it gives you most of the information you need to create an extension. Creating an extension in review board is very documented, it's heavily documented, so most of what you need is included in this page. For me, I have an extension.py class that hooks my extension to the diff page and to the review request detail page. And I also have a web API resource that grabs the current review request ID and calculates the reviewers for only that ID. So I made it extremely lazy in the sense that I don't calculate anything until I need the reviewers. And then I also have a JavaScript class that makes a call to the web API resource, passes in the review request in the URL, and then returns the reviewers and inserts it into the page if there are any reviewers. So if there's no one suggested, then we wouldn't get this block of HTML added to the actual page. And then here, if you look at my last video, I went in detail over how I calculate reviewers, and I use a model called KNN algorithm. For those of you that don't know what KNN algorithm is, it's an algorithm that finds the nearest neighbors to an object and returns, when it finds the nearest neighbors to an object, it can tell what that particular object is if you don't know what that object is. So using that in mind, here we don't know who the reviewer for a change set should be. So we find the past reviews that are very similar to this current review request and suggest that the reviewers that reviewed those past reviews. So I wrote some custom functions called calculate distance between files, and recently I added calculate distance between file extensions as well, and I'll go over why I added both of them as opposed to just using one distance. And then using this distance, I get the most similar neighbors to the file to be reviewed, so here. And then using the get neighbors, I get the best reviewers, so the reviewer that has reviewed the most similar reviews to a review request, I return that reviewer. So as to why I decided to use this weight and use these distances, I did some testing to calculate the accuracy of my model. I wrote a script called suggest reviewers accuracy. Our review board was so nice as to provide a training set for me. So they gave me about 7,000 reviews that have been done recently on public review board, and I randomly assigned those reviews to the training set and the test review set. So each of the reviews in the test review set would have a list of suggested reviewers. So here I have the same model as I have currently now. The only thing that really changed is the get neighbors. So in the get neighbors, I played around with different weights, and here, as you can see, I also have a third distance. But the reason why I decided to remove it was in my results, anytime I included a weight for the third distance, I would get a lower score. The one time where I had 0 as the weight for the comment size, I had 77%. That was because at the very beginning when I started this project, I thought that the length of the comments, so how long someone writes, would um, be a good predictor for who is best to review a particular chain set. But I was wrong because anytime I added this weight, it it reduced the accuracy of my model. So this is why at the end of the day, for the current machine learning model, I decided to put 1.5 for the distance between files, and then 1 for the distance between file extensions, and I don't use the comment size at all in the calculation. So now to show you a quick demo of how everything works, let's just go ahead and choose a random chain set. So first of all, in my users, I created a few users here. So I created 6 users. So now let's just go to any change that I've not used before. Let's go with this. So fix a JS crash when going from an inter-div to regular div with comments. And then we're going to see that the page would load first to give the user the full information, and then suggested reviewers are, or is in this case, just one person, Praise A. Because Praise A, if you look at my last video, has reviewed the most files out of all these users. So let's just take a quick look at the div. In the div, it's a JavaScript file, and Praise A has reviewed a lot of JavaScript files. So then we can just go ahead to use this suggestion and add Praise A as the reviewer for this file, publish it, and this extension will just be really good for organizations where they're not sure which person to add as a reviewer for their chain set. Let's say they're just new to the organization or something like that. This suggested reviewers um, um, addition here would comb through all the previous reviews and suggest someone that is most likely to understand the new changes that this person is making to the code base or to the files that the person is changing. I hope this video is helpful to you, and thank you so much for listening. Thank you so much for your time today. Have a great day. Bye.